All right, welcome back, Gold Group. I'm going to move on to the second part of the lesson. Make sure you click on the Intersecting Linear Model Systems doc, and this should be what comes up on your screen, comparing two attractions. And I'm going to go through this with you. So again, feel free to do a split screen or click back and forth. Please pause when I ask you to pause so you can try some on your own, and then you can come back and check it against mine. All right, so we are comparing two attractions on this dock. It says a resort has two main attractions, the Big Fun Amusement Park and the Get Real Movie Multiplex. The number of visitors to each attraction on a given day is related to the probability of rain. So the table below shows the attendance and rain forecast for several different Saturdays. So we have two parts of this table. We have the first two rows that are talking about the amusement parks with the probability of rain, and then we have the attendance. As we can see, our probability of rain would be our X variable. It comes first in our table, and our attendance is our Y variable. So as we can see, as the probability or percentage of rain is increasing, what's happening to the attendance? Well, we can see that it's decreasing. So if we think about that, as we have a bigger probability of rain, less and less people will want to be spending their time outside at an amusement park. So that does logistically make sense. And then we have, looking at the movie theater, we have the probability of rain again. That's our X variable, and that's increasing by 20% each time. And then the Get Real movie theater attendance is actually increasing. So if we think about that, as there's more and more probability or percentage of rain outside, more people probably want to be going inside the movie theater because it's inside. You wouldn't want to be outside when it has 100% chance of rain, as much as being inside. So we just want to first look at the table, make sure it makes sense. And then if we scroll down, it actually says the same company owns both businesses. The managers want to be able to predict Saturday attendance at each attraction so they can assign their workers efficiently. So they want to know where they should be putting more of their workers to, depending on the percentage of rain for that Saturday. So we actually have both pieces of data already in our table. We have our X variable down here, our probability of rain, our Y variable, the attendance, and they graph both pieces of data on the same graph. We have the Get Real Movie Theater is the blue, and the Big Fun Amusement Park is the green. So we'll be using both the table and the graph to help us answer the several few questions. All right, so going down to number 1, it wants us to use the graph or the table to write an equation relating the probability of rain to the Saturday attendance at Big Fun and the Saturday attendance at Get Real. All right, so let's start with Big Fun. So when we scroll up, we can either look at the table or the graph. If we look at the table and we're finding the slope of that table, we'd have to use our rise and our run, which we absolutely can do. It's a little tricky on the graph though because of our scales. So when we look at the scale here on the x-axis, many of you might think it goes up by 20, but actually the scale is by tens. Even though it doesn't have a 10 here, it would be 10, 20, 30, 40, and so forth. So the scale here is tens. The scale on the y is actually 100, 100, 200, 300, and so forth. Because we have such a big scale, it makes it a little tricky to do our rise and run. So I think it's easier to actually use the table. So I'm going to scroll up to my table. And we know that if we're finding slope of a table, I want my change in y over my change in x. So if I'm starting with my y's, going from 1,000 to 850, we would be subtracting. And if you type that on your calculator, you'd see that you're subtracting by 150. And then the next ones, you're subtracting by 150, by 150, 150, 150. If we look at our x's, we're adding by 20 every time. So to find our slope, our change in y is minus 150. Our change in x is 20. So when we go down to our slope down here, we can type in negative 150 over 20. Now we usually want to simplify that, so if possible we want it to get to be a whole number. So if we type that in our calculator, it does not give us a whole number. So we want to simplify it as easy as possible. So when we type negative 150 divided by 20, we'd get negative 7.5. So negative 7.5 is our slope. So we'll be using that when we go to plug it in our equation. All right, for our y-intercept, we can look at it in either the graph or the table. So if we look at it in our graph, big fun, we want to see where that line crosses the y-axis. So we can see that's right at 1,000. To double check, just because our scale is so different right there, we're going to go up to our table. When we have a table, we'd find the y-intercept by looking where the x is 0. So 0 is right here for the x, and our y would be 1,000. So it actually is 1,000. So our y-intercept, 1,000. When we plug that into our equation, we're going to use our slope-intercept form equation, y equals mx plus b. So we're going to keep the y because we can use for any variable. M is our slope, so negative 7.5. X we're going to keep because we're going to plug in some values for that. And then we're going to add in our y-intercept, so plus 1,000. All right, so do a quick check. Your equation should be y equals negative 7.5x times x plus 1,000. All right, go ahead and work on the next one for Get Real Movie Theater. You'll have to find the slope, the y-intercept, and then type in the equation. Pause this video, and when you unpause it, you'll see what I have. All right, hopefully you had time to look at the Get Real Movie Theater slope, y-intercept, and equation. When you look, again, I think the table's easier because of the scales on the graph. So you can see that the y is going up by 40 every time. The x is going up by 20. So when we plug that into our slope-intercept, or our slope, that'd be 40 over 20, which equals 2. The y-intercept, which is where the x is 0, is 300. So your equation is y equals 2x plus 300. All right, let's move on to identifying the variables. So you can either look at the graph or the table. If you're looking at the graph, you're looking at the labels. If you're looking at the table, you're looking at the labels. Just make sure you look at the right one. So for our x, it's the probability of rain and percentage. And in our graph, it's the same thing right here, percentage probability of rain. So we're just going to type that in for x. And then for our y, we're going to go up and look at the y-axis in our graph, which says attendance. And it's attendance of both of them, so we could use that same label. The only thing is we want to have total of in front of it because we always want to have the y having total of as part of its label. So total of people attending, or total attendance would be fine as well. Okay, so now we're going to be analyzing these equations. We're going to be using the equations we found, plugging in pieces of data, just making sure that we are using the right variable for each one. All right, so number one, suppose there's a 50% chance of probability of rain this Saturday. What's the expected attendance at each attraction? So if you look at what's given to you, they're telling you that it's a 50% probability of rain. So that's the key part that they're giving us. We need to know if that's our x or our y. So if we go back up to the previous question, probability of rain, that's our x variable. So we're going to plug 50 in for x of our big fun equation. And again, right up above that is our big fun equation. So y equals negative 7.5x plus 100. You can either copy and paste that down here or retype it. All right, and then as we mentioned, probability of rain is 50. That's our x. So we're going to plug in 50 for x. Everything else stays the same. Just like in our warm-up, our y is over there all by itself, so all we're doing is using our order of operations. So again, you will definitely need your calculator here. Negative 7.5 times 50 is negative 375 plus 1,000. Type that on your calculator. You get y equals 625. Now, this one being a word problem, we shouldn't just end with y equals 625. We should explain what that means. So the question says, what is the expected attendance at each attraction? So they're wanting the expected attendance. That's what they're asking for. So y is the 625. So 625 people is the expected attendance. All right, and there would be our final answer. So we want to make that stand out, either highlight or bold it, as that's your final answer. Okay, you're going to do the same thing now, but using the Get Real Movie Theaters equation, still 50% probability, so plug 50 in for your X, see what you get. I'll pause it right now so you can try it on your own, and then come back and we'll check. Okay, hopefully you've had some time to work on the Get Real Movie Theater. When it has a 50% probability, what's the expected attendance? So you'd use that equation that we came up with above, plug in 50 for X, and you should have got right here 400 people would be the expected attendance. So go ahead and check your work against mine. Make sure you have a nice final answer with your label. Okay, next we are looking at another question still using our equations. So suppose 460 people visited Big Fun one Saturday. Estimate the probability of rain on that day. So we're only looking at Big Fun amusement parks, and we are given 460 people. So that's the piece of information that we're given. Okay, so we should figure out, would that be our X or our Y? So they're telling us the people. If I scroll back up, here's my variables. So our number of people is our Y. So they are giving us the Y variable. So when we use our equation for Big Fun, that equation is Y equals negative 7.5 X plus 1,000. We're going to plug in the Y this time, which is 460 equals, the right side stays the same, negative 7.5x plus 1,000. We really want to try to get that equal sign underneath each other, so feel free to reformat or space it over. All right, so just like in our warm-up when we are solving two-step equations, if the x is over here with some other things, we have to do the inverse operation. So first thing we're going to do is get rid of this plus 1,000. So we're going to minus 1,000 on both sides. All right, there we go. So on the left, 460 minus 1,000. Type that in your calculator. It does equal negative 540. On the right-hand side, when I do all that calculation, negative 7.5x, and then I have plus 1,000 minus 1,000. Those cancel each other out. All I'm left with is negative 7.5x. All right, so I have a simplified equation now. So now I still have to get the x by itself. I'm multiplying right here. So the inverse is dividing. So I'm going to underline both sides to show my division. And I'm going to divide both sides by negative 7.5. And that should not be underlined, so I'm going to fix that. All right, so when I solve that left side, negative 540 divided by negative 7.5, type that on your calculator. You do get 72 equals, and all you're left with on the right is x. So my final answer is 72 equals x. When I go back up and look at the question, estimate the probability of rain on that day, and x is my probability of rain. So I would say that the probability of rain is 72%. All right, and that would be my final answer. All right, the next one I'm going to have you do on your own. It is the same type of problem. They're giving you the number of people. So that's our Y. You're going to plug that into your equation for the Get Real movie theater and see what your probability of rain would be for that question. Okay, pause it now. Try it on your own, and when you come back, you can check your work. All right, when you went ahead and plugged in for the equation y equals 2x plus 300, you plug in the 360 for your y. You're going to have to do some inverse operations. You should end up with 30 equals x. So that probability of rain is 30%. All right, nice job. Okay, we have a couple more to finish this up. So now we're going to look at the graph and we're going to find the probability of rain for which the predicted attendance is the same at both attractions. So we're looking at that solution to the systems. So when we look at our graph, we have two systems. We have the Big Fun amusement park system, and then we have the Get Real movie theater system. So that solution is going to be where they're crossing together. So I have my cursor right here where they're crossing at the same point. Now, before Thanksgiving break, we were practicing this, and it was always a coordinate. So it landed right on one of those lines, and we could easily see where that spot is. This time it's a little different because it doesn't fall right on there. So we're going to do our best judgment and see what's the probability of rain. So when we probability of rain is down here on our X, when we kind of bring that down here in the straight enough line that I possibly could, I can see it's a little bit more than this big line here. So when I know my scale's 10, if this is 60, this has to be 70. So it's a little bit more than that. So I'd say maybe around 72 or 73%. And that's all they want is what is the percentage of rain. So when we scroll back down to number 4, we could then type our answer. What's the probability of rain? The probability of rain would be about 72% because that is where the lines, I like that, intersect. All right. So all they wanted to know is the probability of rain. In the next question, we're going to see the visitors. So we can see actually both parts of it. All right. The last part just explains some vocabulary. So we've been talking about this solution to a system in the past couple classes. So it just reminds us that when we're comparing two equations, that's called the system. And then where they intersect, that x and y are the same for both equations, that intersection, that's called the solution. So that's what we're trying to find is what's the solution to the system in these two equations. So what it tells us about the location. So we already know that that's 72%. But when I match it over here with my y-axis, right here, again, is that intersection. When I go over here, I know my scale is 100, so I know it's between 400 and 500. I'd say it's pretty close to right in the middle. It might be a little higher, but probably around 450, 460 visitors would probably be the attendance at that intersection at 72%. All right, so to type in our last answer, when the probability of rain is about 72%, they should expect about 450 visitors. So again, when we were doing before break, when we were looking at that exact coordinate, we're going to have to try to get as close as possible. That's why we have about in here twice, because we did have to kind of use our best judgment, knowing what the scales were, to find that answer. All right, so when you have that final answer, you can go ahead and Click out of this, go back to Google Classroom, and if both of them are done, you can click that turn in button and you are good with the remote lesson for today on Wednesday. A reminder, when you come to school on Thursday, make sure your remote work from the Friday before break is done. That Friday before break lesson was called Solutions to Systems by Graphing, and it was a worksheet that I passed out in class. I believe I also had the digital copy, but it's a lot easier to do it by paper. This was your remote lesson for, I take that back, that was for Monday of Thanksgiving week, Monday, November 23rd. So make sure that is done and you'll be ready to check that over and move on. We're going to start a new topic when you come to class on Thursday. All right, thanks everybody. I hope you learned a lot. Hope you got both of these done, and I will see you on class on Thursday. All right, bye-bye.